This is part 4 of graphing quadratic functions, and in this video we're going to look at some applications of these kind of functions. If you haven't watched the other videos, you may want to do that. In the previous video we talked about this formula, f of x equals ax squared plus bx plus c, and finding the vertex. So we're going to look at an application problem. So here it is. The number of mosquitoes, m of x, in millions in a certain area depends on the June rainfall x in inches. So x is the amount of rainfall in June given in inches. According to the formula, m of x equals 5x minus x squared. What rainfall produces the maximum number of mosquitoes? So let's first understand what's happening here. We've got this formula, m of x equals 5x minus x squared. So x is the number of inches of rainfall, and m is the number of mosquitoes in millions. So if we think about what this graph is going to look like, it's going to look like a parabola because it's got an x squared, and it's going to look like an upside down parabola. Now if we wanted to put it exactly in this form, we could put the negative x squared first and then the plus 5x term second. So our a value here is negative 1, which tells us the parabola opens down, and the b value is 5. If we were to look at a graph of this, we would really only want to consider x values that were positive, because x represents the rainfall in inches, and we're not going to have negative rainfall. And m of x represents the millions of mosquitoes, how many millions of mosquitoes, which is going to be a positive number. If it came out to be a negative number in this formula, we would just say there was no mosquitoes. No mosquitoes would be around. It wouldn't be negative mosquitoes. So the question is, what rainfall produces the maximum number of mosquitoes? I'll give you the short answer here. No, I won't. Let's work for it. Alright, so if we were going to graph this, we would want to plot some points. And the first thing we would want to do is find our vertex. Okay, so we're going to use our formula, opposite of b over 2a. So my b value is 5, so the opposite of b is negative 5. And my a value is negative 1. So positive 2 times negative 1 gives me a negative 2 on the bottom. And that tells me 2.5. So my vertex is 2.5 something. And in order to figure out what that is, I have to plug 2.5 back into my equation. So let's keep in the frame of mind of the context of the problem. What does the 2.5 represent? That represents rainfall in inches. Okay, so if I have 2.5 inches of rainfall, I plug this in, it's going to tell me, I'm going to go ahead and use the first version, it's going to tell me how many millions of mosquitoes I will have. Approximately, right? Okay, so 5 times 2.5 is 7.5, and 2.5 squared, I think that's 6.25. So you can double check me, but I think that's right. Okay, so 6.25. So 7.5 take away 6.25 would be 1.25. And that is in millions. So if I had a graph here, I'll just do a little rough graph. My vertex would be at 2.5 and 1.25. So let's make this go 1, 2, 3, 4, 5. And we'll spread this out a little bit. Let's go like a half, 1, 1.5, 2. Okay? So my vertex, 2.5, let's do that in a different color. 2.5 up 1.25 would be about right there. Now I'm not going to go ahead and graph the rest of the parabola, but let's think about what we learned about the a value. The a value here is negative 1. It's also found here. What does that tell me about the parabola? It tells me it opens down. Okay? And also, it's going to be a standard shape parabola because the a value is absolute value of the a value is 1. So it's going to be not any wider or not any narrower than just a standard y equals x squared parabola. Okay, so it's going to look something like this. And I could find these exact values if I needed to. But in this case, I don't need to. Oops, sorry, that was a little bit rough. That's okay. Because the question is, what rainfall produces the maximum number of mosquitoes? Well, like I said a second ago, if it goes negative, we don't care. So really, this stuff, I don't care. This stuff, I don't care. Okay? This is the range that I want to look at. This is my number of mosquitoes, how tall it is, and how far over is my rainfall. So this range of, I should say, range of x values, which is kind of weird because we talk about range as y values, but this area of x values is going to produce some mosquitoes. This amount of rainfall is going to produce some mosquitoes. Where do I have my maximum number of mosquitoes? Right here at my vertex. These are my mosquitoes. So really, in order to answer these kind of maximum or minimum questions, all you have to do is find the vertex. That's it. That's what I was going to tell you at the beginning, but I think it was better to sort of develop it a little bit. So 2.5 inches of rain is going to produce 1.25 million mosquitoes, which is the maximum number of mosquitoes I could get according to this formula. So the answer to the question is 2.5 inches. What is the maximum? What rainfall produces the maximum number of mosquitoes? 2.5 inches of rainfall. Okay? It's a vertex question. You need to recognize that you've got a parabola and then basically you just find the vertex. Alright, well I hope that helps, and you'll usually see these maximum and minimum type problems in a quadratic equation. Anytime you're graphing parabolas or graphing quadratic functions, you're going to see maximum and minimum problems, and what you're doing there is you're finding the vertex. But sometimes it helps to draw a graph. Now, one last thing I'll say, we had an upside down or a downward opening parabola, so therefore we had a maximum. In different applications, in different story problems, you might have a parabola that opens up. You know, the graph of it's going to go like this, and your a value is going to be a positive. Then they're going to be asking you for a minimum. They're going to say, what's the minimum amount of something, or what x value will produce a minimum y value. So get an idea in your head of what the graph looks like if it's opening up or opening down using the techniques that we used in the first few videos.